All right, so let's continue now looking at direct and inverse variation. So when we look at different concepts that change in tandem, sometimes they vary directly, sometimes they vary inversely. So we mentioned earlier that the more tomatoes I buy by weight, the more I'm going to pay. That's going to be an example of direct variation. And we also had the filling up the water balloons. The more water balloons, the more the radius of a water balloon increases, the more the volume increases. That's going to be a direct variation, but a cubic one. We can get an inverse variation. Such as, let's say we're building a wall. The more people we have, the less time it's going to take between how long to complete the building project. If we're gathering things in a field, so we're bringing in a harvest in a field, the more people we have, the less time it's going to take. These are inverse variations.
What does variation mean? Is that change?
Yeah, how the change in tandem goes. So how they vary, how one means they go together. So the change in what we started. So we're ending the unit with change in tandem. We started the unit with change in tandem. How one thing changes as another thing changes, and what the rate of change is. So we can often look at this as a system of variation. And if we say here, we can say that y varies with x to the n. If we wish to turn this into an equation, for instance, bringing back to the tomatoes, if I buy 1 kilo of tomatoes, do I pay 1 dirham? No. But how does the model work? We have to have some kind of a constant that creates balance there, and that's the price per kilo in that particular example. So as we go up, the K value would be your price per kilo. Your N in that case is going to be 1 because it's a linear model, but this is a direct proportion. With these type of graphs, they are not they look like linear graphs, but they're not, because they're basically not going to have a y-intercept constant. So they're going to look like this. This is direct variation. Inverse variation is going to look like this. So an inverse variation is going to look like this. As x increases, y decreases. And that's why it looks like a rational function or a reciprocal function. And you still need this constant of proportionality.
What does K stand for?
K is the constant of proportionality. It's what, like in the example, sorry, I can't speak and spell at the same time. Proportionality. Like in the example of the tomatoes, it's the price per kilo. That's what the K is. There's some kind of a constant that creates this balance. And typically our problems are going to be involved around finding that constant first. So things can vary directly in a linear pattern, but they can vary directly in a x can vary with the square, y can vary with the square of x, or y can vary with the cube of x, like radius to volume in a sphere.
So the example that you said is that it doesn't have a power.
The n would be 1, because it's a linear variation. All right, let's have a look at an example. So here's our example. The distance d that a rock falls varies directly with the square of the time taken. The distance d that a rock falls varies directly with the square of the time taken. So coming back here, we're going to need this. This is direct variation. We're going to need this. So if it varies directly, we can say for A, we've got two things. We've got d, which is our distance. It's going to vary directly with t. And it says that with the square of the time taken. So we've got this. D is proportional to t squared. This implies that d is going to equal k times t squared. So when we move to the equation, you add in the constant of proportionality. You don't need it for the proportionality statement at the beginning. This symbol here is the proportional symbol. It's like alpha in the Greek alphabet, or the Jesus fish, whichever you wish to use. Okay. So what we're going to do on this one, we've got some values here. So in A, it says if a rock falls 6 meters in 2 seconds, write the statement of D in terms of T. So the distance is going to be, if we're going to enter this coordinate, we've got 2, 6 as a value. So 6 is going to equal K times 2 squared. So that means that K is going to equal 6 over 4. 3 over 2, 1.5. So obviously this is on a much smaller planet than ours, as the gravitational force is much less than G. What is the value of G? Okay, there we go. It's actually 4.8. 9.81 would be when you derive it. But yeah, this is distance, not velocity. Okay, so we've got our K value. So looking at B, find the distance the rock has fallen after 5 seconds. So we've got our model now. D is equal to 1.5 t squared. So we need to find D of 5. So 1.5 times 5 squared. Pop that into our calculator on this one. 25 times 1.5. 37.5. What's the units? Meters. What's the units of K? What's the units of K? Sorry? It has units. It has to.
1.5.
No.
Then we just work out.
You can work. What, this 6, what's the units of that? Meters? This 4, what's the units of that? So this is in meters per second.
You're working out gravitational forces. Isn't it in G?
Yeah, but 1G is because we're on Earth. All right, have a go at this one for yourself. I'll give you 5 minutes for this one. This. All right. So we got an X-ray machine is used to eliminate germs from certain foods. Intensity in millirads per hour of X-rays produced by the machine is inversely proportional to the square of the distance in meters from the machine. For a certain machine, the intensity is 26.5 millirads per hour, a distance of 4 meters. So let's see what it says first. Let's pick this one apart. Intensity, that's what we're after, is measured in millirads, produced by the inversely proportional to the square of the distance d in meters. There we go. So let's write that down as a statement. It says this is inversely proportional to the square of the distance. This implies that I is equal to k over d squared, which implies if we stick in our 2 things, we've got 2 pieces of information. This one, is that an I or a D? That's an I, isn't it? 26.5 equals k over, and then we've got another piece from the distance there. That's a D, isn't it? So 4 squared. Solving that, we get k is equal to 26.5 times 16. 424. Document 72. Just going to check my calculator's not in float 3. Yep, that's right. So we get this one. So therefore, the intensity is equal to 424 over d squared. We're asked, based on this information, same machine, what is the intensity when the distance is 3.3? So I of 3.3 is going to be 424 over 3.3 squared. And I get 38.9348 ... which is approximately 38.9. I need to give the units, so I'm not quite sure how to write millirads, so I'll write millirads. Okay, have a go at this exam style question. We get 2 minutes for this one. Okay, so let's have a look at some exam style questions to finish off today. Our first one is looking a little bit at domain and range. So we have an open top box. We're cutting off a square from each corner. And it's 11.2 inches by 13.3 inches. And we have to figure out what is the domain of this one. All right, okay. So we need a sketch. We need a sketch of the problem here on this one. So we got a piece of paper that's going to look like this. And we're cutting off some little squares like that. And the length of these squares is going to be x. Then if you imagine, we're going to fold it along these little lines here. And we can turn it up and we can turn it into a box. So, in the situation, what is the domain going to be restricted? What is the x values? Let's have a little look at that. So, our x values, so there's two ways of looking at this. We can solve this with a graphing calculator, or we can solve it by thinking it through a little bit. So we've got 11.2 as this distance here. And this distance here is going to be 13.3. So this length here is going to be 11.2 minus 2x. Sorry, 11.2 minus 2x. And this one is going to be 13.3 minus 2x. The volume is when we multiply those two together, and that's been done for us, and they give us this volume here. So if we're looking at the domain is going to be restricted by the fact that the x value can't be bigger than that, because then you wouldn't be able to have two of them. So 11.2 would be the biggest that we can have. Oh, no, sorry, no. Yeah, we got to halve it, don't we? Yeah, we got to halve it. So we take the 11.2 minus 2, sorry, divide by 2, and we get 5.6. Because this is shorter than that one. No, the domain is simply what the x value can be. Sorry, can we just stop the chat for a second? I'll give you a minute to talk about the question. So thinking it through logically without the calculator, we can look at it that way. And this is going to give us our two possibilities. So we will get another value of 6.65 made by the other side, but that side the x can't be more than, can't be 6 on that side, because it will give us 12 on the other side. Two x's would be 12 if they were 6. And that's not going to fit for us. That's not going to work. Okay, so just having a quick look on my graphing calculator for this one. So if you take your graphing calculator, notice we're given the function. We've got the function, and we could sketch that. So I'm just going to add a graphing page. And we want to type our function in. Our function is 4x cubed. Sorry, it's not coming. 4x cubed. Type it into your calculator. Minus 4x squared plus 148.96 x. Just zooming out a bit here on the calculator. Closing in this, we can't have a x as a negative length, so it has to be positive. And we can use the calculator to find the 0 here. We can't have a negative volume, that would make no sense. So we see there on the calculator that the answer is going to be 5.6, which is another way, if you have the calculator, of solving this problem. Okay, our last question for today, have a go at this one. We want that. All right. So Jordan's cell phone plan includes 5 gigabytes of data per month, and that's costing him $79.95. If he uses more than 5, there's a charge of 10 for every additional data used, which is the model. So how's it going to look? Let's do a little sketch of how it's going to look to begin with. So it's going to look like this. It's going to be at, what was that? $79.95 across to this point here. And this is the 0.5, 79.95. It's then going to go up like this and continue. And the slope of this line is going to equal 10. So looking at the different models, which model is this one going to be? Well, this one here at the bottom is not going to work because this one is going to be 79 and then 10 for every, so that's a linear model. So I can sketch that one quite easy. D is going to look like that. So let me make it parallel. D is going to look like that. That's D. It's not this one. This one, look, what is this? So it's going to, for every data we use, it's going to be 79. So that one's insane. So that one's going to look like this. It's going to start here at 10, and it's going to go up like this. That's this one. Oh no, wait, it's not. So okay, all right, let me see it. Yeah. So this one is actually does have a piecewise. It's going to go across, but then it's going to go up at a value starting down here, or 5 times, what was it? 5 times 79. Okay. So it's going to go across in the right place here, but then it's going to start at quite a high value and go up in this direction. Oh no, my video ran out. My recording's gone. Okay, so for this last one, let me try and sync these two. We need to use we need to use something that is the problem with, where's my highlighter pen? The problem with this one is it's not going up. Sorry, the problem with this one here is it is going up by 10, but when we put in d equal to 4, we're going to be adding on 40. We shouldn't be adding anything until d becomes 5. And it's this piece here does that for us. So as long as d is less than 5, it's not going to be adding anything on to us. But to stop it messing the first part of the model, so this bit here is going to stop it not adding anything until d is 5, and it won't add anything of that because of this. So until d becomes 5, it doesn't add, this bit doesn't work. So from 0 to 5, we are going to go at 79, and then for every d more than 5, we're going to add one lot of 10. So our correct answer is A. Our correct answer is A here. All right, that's it for today.